Hi, everyone. My name is Bill Bass. Our team runs about 72 systems here at AWS. That includes everything from our IoT and industrial solutions, robotics, autonomous systems, edge computing and edge storage, streaming, and a lot of the products our customers are using to extend the cloud out to the edge to meet their industrial needs. So what is the edge? From our definition, it's probably where you're sitting right now, unless you're sitting in an AWS availability zone data center. We have customers, for example, like iRobot, who are managing millions of robots at the edge, automated driving systems, customers that are collecting and processing data in car, along with our autonomous systems out there, customers that are operating edge IoT devices in hospitals, and all the way out in the ocean, where there's marine collection being done and processed on snowballs and industrial settings and oil field settings, things like that. So the edge is sort of where you are today, and I think that's an important piece. So the edge loads, they're based on sort of we refer to as the three laws here. So the law of physics. In a lot of cases, you can't overcome the speed of light. You need processing that's local, super low latency. For example, for SCADA systems and PLCs, robotic control systems, driverless car system, things like that. The law of economics. We have a lot of customers that are collecting many petabytes at the edge, whether you're doing movie shoots or seismic data collection, or a lot of scientific data collection happens at the edge, and it's just too expensive to send that data and too slow to send it over the network. Or the law of the land. There are a number of countries that have data residency requirements, and local edge processing and storage allows you to meet those residency and compliance requirements that you have. Our goal here is to really make it simple to deploy out to the edge, so that you have a seamless development, connect, deploy, manage, and security controlled environments from the very edge, where you can have that very low latency processing. And we want to provide a broad range of cloud services and consistent APIs, so you only have one programming model that you can use everywhere. So for example, you can deploy a machine learning function or a Lambda function or a container-based application at the edge on a device, or in a 5G hub, or in a data center, or in a CDN or POP, or back in the cloud, and it'll be consistent across those areas. And you can do decentralized execution for low latency, and centralized control and centralized management. When we look at the edge to cloud architecture, we sort of start at what we're working on in microcontrollers and IoT devices, where we look at networked environments like factories and robotic systems and things like that. Telco environments, where we're working with a number of telco providers for 5G hubs, because those provide low latency and local processing there. The rugged edge, which is usually disconnected, and ships and planes and forward deployed units and oil rigs and things like that. On premise, inside data centers, metro centers with local zones, and then all the way back to our regions and our POPs. So we have a very large number of regions with many availability zones. Our regions always have at least 3 different buildings that are 10 to 60 kilometers away from each other, with the data striped across those for durability. But we allow you to push your processing out all the way to the edge and then manage it from the cloud. So these are some of the products that enable that. On the device side, we have things that I'll be talking about, like free RTOS and Greengrass and Kinesis. We have networked environments like Sitewise that let you look at whole sites, the telcos, the rugged edge. All of these things we'll be covering in detail. So let's start with microcontrollers and IoT devices and devices that are running out on the very edge. So one of our products is free RTOS. It's the most common MCU operating system out there today, and it's an operating platform. You're usually running your application and running this on the bare metal. It provides local connectivity. You can communicate back to the cloud. It's got very secure and security control systems in place, and over-the-air updating, which is really important, along with code signing to ensure that you're authorized to do that over-the-air update. And then we also provide long-term support. And of course, like with all of our products that run on other environments, it's open source. And then for more sophisticated devices that have an operating system underneath them, whether that be something like Yocto or Ubuntu or Windows or whatever, we have Greengrass. So Greengrass, which we just released as version 2, which is a major update for us, it has a security and secrets manager on it, so you can manage secrets like SIMs for connectivity to cellular and things like that. And rotate certs and those kinds of things. It provides local messaging within the device and across devices without having to go up to the cloud and come back down again. Provides local actions, so you can run a Lambda function or a container there locally and put, say, a scale of vector model or machine learning model there and react to it locally and manage those. And it allows you to deploy and manage the code out locally on those devices. One of the things I really love is Stream Manager, which allows it to effectively move between and discover different radios of communications and handle the complexity and security of communicating for you. So you can take advantage of LoRaWAN, or you can take advantage of Wi-Fi, or you can take advantage of Zigbee, or you could take advantage of cellular or satellite or whatever is available to you out there. And then we have an ML interface that allows you to manage your models as well, because lots of our customers like to do local machine learning on the device and use that for filtering data. And of course, Greengrass is open source as well. And we have great partners out there like Siemens, who we work together with on MindSphere. And so Siemens, connects up to 80% of the industrial world worldwide. They're using our IoT platform to take advantage of the complexity of the communications and the scalability that we offer to handle billions of devices and being able to scale out there. And they're a close partner of ours that allows us to, where they have the experience in the domain, and we partner together on deployments for factory automation and industrial automation. Another one of our great partners is Hitachi. They're one of the Gartner's Magic Quadrant leaders, of course. And again, we've partnered with them for industrial solutions and industrial IoT solutions. Another great partner that has domain expertise, but is leveraging the very sophisticated capabilities that we offer for edge processing and IoT processing, streaming, and the back-end and security management systems that we have. So some of the other products we have that people could take advantage of is things like Monitron. So if you need to run at the edge very quickly, this is a local group of sensors that primarily sense vibration and temperature. They connect to the hub and allow local ML processing right there, and then can connect back to the cloud. And then to do predictive maintenance and those things, we've pre-created a whole bunch of ML models. So if you can send your data right up to the cloud and you don't need to process it locally because you have better networking, you can use Lookout for equipment. So you can stream your data up to the cloud, do the same processing you would do on Monitron, but you just do it in the cloud without having to have any devices out there. So this gives you a lot of flexibility depending upon what amount of network you have and what amount of latency you need for your responses there. In addition to that, in the machine learning space, we have our Panorama appliance, which gives you the ability to turn cameras into IoT sensors using ML. And the Panorama is designed if you have existing or older cameras that don't have local processing on them. And then we have the Panorama SDK. So if you have a smarter, newer camera, you can put that logic on the camera and run your ML right there. And then using Kinesis Video, stream it up to the cloud when you want to see it. And then Lookout for Vision If you just want to have your cameras streams directly into the cloud and do all that same processing in the cloud, that's you can do that with Lookout for Vision. These are very powerful tools that allow you to detect anomalies, allow you to detect defects, allow you to count things like number of people or see smoke, or and you turn the camera into a very sophisticated and capable IoT device that's very multifaceted and very inexpensive as well. Cargill has a great application where they're using Panorama. So as trucks come into their depot, they know in their system, they used to manually tell the trucks where to go, but now in their system, they can see the sizes of the trucks and then route the trucks to the proper loading dock based on their size. And that's done by processing on the camera. And that sort of tipping and queuing there is a great example of how to use these cameras. So if you take a look at the networked environment out there, things like factories and smart buildings, things like that, we have a product called Sitewise. So Sitewise aggregates a bunch of IoT information and sensors that are occurring in a location and allows you to get a good information on it and the status of it and manage it. So you can ingest all of this equipment data, you can create asset models, and you can set rules between assets. If this fails or that fails, or this alarms or that alarms, you can manage a dashboard for that. You can store the data in a time series database, and then you can create your dashboards and build your alarms and your pages based on that. So it's what people use to manage large sites. And then, of course, we have Robomaker. And so Robomaker is, at Amazon, we run about 250,000 robots, and we have to maintain them and do fleet management and those things. So Robomaker allows you to very quickly build the software for the robot and test it, and then have synthetic worlds to simulate it in for the machine learning, things like that. And you see an example of a hospital there where both of these robots here were used for COVID sanitation and support for hospital operations. And then you can do fleet deployments and management of your robotic fleets. And you see one of our smaller fulfillment centers there on the deploy side. So it allows you to sort of do this end-to-end management system of deployment of robotics, drones, autonomous systems, all those things. Robomaker is a great solution for that. And you can see one of our customers here, Milbus, who has a sterilization robot that they trained it on Robomaker, they built the software on Robomaker, and then they use it to deploy and manage their robots. And this is a robot that goes through and sanitizes. And they just were able to do it tremendously faster than doing it manually or building, their own physical environments to test in. You can spawn out tens of thousands of virtual environments to test in, run your machine learning models. When you're happy with it, you can push a button and deploy that out to your fleet and manage your fleet. And so Robomaker is designed to make the management of those infrastructures much easier. Now, Wavelength is a very exciting product where we're going through and pushing the AWS cloud right into the 5G hubs that are out there. So you can deploy your applications that you would deploy in the cloud also locally in 5G hubs. It gives you this very low latency with 5G connectivity because you're in the hub, a consistent developer experience, the same benefits you get in AWS, low cost and super secure, and a broad coverage with these hubs everywhere. All right, so here's a great example of one of our partners, Tata, who has worked together on Wavelength with us and Verizon to do factory automation delivered from a Wavelength hub due to its low latency. So let me turn it over to them so you can hear about it.
Hi, I'm Shanky Vishwanathan, CTO for Communication, Media and Information Services at Tata Consultancy Services, TCS. We are developing a lot of innovative solutions around smart factory, which necessitates high bandwidth, high reliability, and low latency requirements for a connected digital ecosystem within the shop floor. Let me take a particular use case within the industrial manufacturing setup, which is called end-of-line quality control. Traditional approaches have been either manual quality controls or very localized edge systems doing visual analytics. In this pilot with Verizon and AWS, high-resolution cameras take video and stock images of the objects passing through the production line. These are shipped through Verizon 5G to the MEC, where an Amazon wavelength edge compute zone correlates these images with stock images of what it has to be. Any deviation in quality immediately gets triggered as an aberration, and remedial action is initiated back to the production line controller or to a supervisor as appropriate. This entire connected ecosystem of high-resolution cameras, the visual analytics ecosystems which operate out of these images, and the low latency response that is needed for remedial action, all of this has to happen near real time, which is exactly where Verizon's 5G, AWS's wavelength, and our solutions come into play. The trial results out of this use case really illustrates how we can harmoniously bring multiple technologies to bear with 5G and edge compute together.
That was great. It's pretty exciting to see how low latency local processing can push the cloud right to the edge like that for manufacturing. So let's talk about the rugged edge. There's a lot of ruggedized environments out there. Not everything's in a beautiful, clean data center or a clean factory shop floor or something like that. And so for that, we have our ruggedized edge processing devices called the Snow family. So here are great examples of it. This provides a device that can handle high impacts, high temperatures. It's triple encrypted, so it's super secure. It can be clustered up to multiple petabytes, and it brings, S3 and EC2 and other things like that right to the edge. We have small devices that call the snow cone there, and larger devices like the snowball you see there that provides a combination of compute, storage, a very high speed 100 gig networking along with wireless networking thing, all built into the device in a shippable, capable processing device there. And also you can use it to transport your data. For on-premise, we have a number of products there that enable local processing on-premise. You can use the snowballs as well, but for more dense compute and things like that, we have the Outpost. The Outpost is designed for data center class environments, whereas the snowball is designed for ruggedized field environments. For example, the Outpost has high voltage and high amperage requirements and heating and cooling requirements, where the snowball runs on just a normal 110 or 240 volt plug and operates in higher and lower temperatures. But one of the cool things about Nitro is Outpost is it provides the Nitro infrastructure, which provides tremendous security at the edge, sort of unmatched security in the cloud, but also out to the edge. It gives you this, it's automatically managed and updated from the cloud, so you don't have to manage it. You can deploy it, build it once, deploy anywhere. And in addition to this full rack, we have 1 and 2U devices coming out as well. So we have smaller form factors as well for field offices and places like that. But it really gives you that extension of the cloud on-premise, and it's used in manufacturing floors and things like that, so you can have this low latency processing right there in your factory. And a great example of that is the work we're doing on DPP with Volkswagen, where they're using our IoT platforms, they're using our Outposts locally, they're deploying it across over 120 plants, and it's using for production control and supply chain automation. And we've tightly partnered with Volkswagen on that. We're pretty excited on how we're working together with them today. So the goal, of course, as I mentioned before, is this centralized control and decentralized execution. So you can have your low latency local execution where you need it. We provide the ability to connect, a lot of different ways to connect, and also run on end devices. We have the ability to deploy and manage and monitor what's going on in there, and the ability, of course, to secure it as well. So we have a lot of very robust military grade security systems, and even things like Device Defender, which will can secure your devices against denial of service attacks and other things like that. So let me talk a little bit about a customer that has sort of pulled all this together into one sort of end-to-end solution, so you can see it all running in the real world. So Woodside's very innovative a company down in Australia. They have about 200,000 IoT sensors for each of their liquid natural gas plants, which we'll see here in a second. They've integrated Robomaker robotics, so the robots can do inspection tours, and even they've trained them using machine learning to turn on and off valves where they don't have automated valves. They've taken our Kinesis video product and integrated in cameras as IoT sensors all over the place. So you can see the real-time video, what's going on, and they're running machine learning models across those. In fact, they're running machine learning models to do things like see the amount of oil that's in a compressor. When all you can see is the glass vial. You'll see that in a second. They're using machine learning to optimize their operations, saving millions of dollars per year in predictive maintenance. They're doing edge computing with things like snowballs. So it's pretty interesting. So what you're going to see is a LiDAR view that was collected with Robomaker drones and robots, a point cloud, and also the CAD CAM view. And you're going to see the daily inspection that's required for health and safety that they can now do in an automated way through this 3D interface. So this is the 3D point cloud. You can see the robot down there doing its inspection tour. You'll see them integrate that here in a second, and you can see its LiDAR in real time. As I zoom in here, the data starts popping up in real time for those compressors. So you can see the real-time data as you zoom in, and you can see the robots pulling in to do its inspection. The manager here has switched to the 3D view. On the 3D view, which is based on the CAD CAM, not the LiDAR scan, so you can see some differences there, they have converted or added the real-time video on top of the 3D view. And right in the center there, you'll see that little 90-degree pipe. The second you'll see the robot inspect that or go past that. So you can see there, I mentioned the oil level. So they're taking the camera. They're also getting audio off the camera, and you can see the oil level. They can do real-time graphs. They can zoom in and see the compressor in real time and how it's running. They can set alarms based on things they see. You can see it now inspecting that pipe there on the robot. Now, the ML tool has made a change to the settings of a valve here. And so they're going to take a look at that, and they're going to send the robot down with this infrared camera to make sure the heat's being dissipated properly there. And you can see it's infrared inspection camera, and you can see the valve opened 100% 11 minutes ago. And so that's part of their inspection process to make sure that's running properly. And now they're going to switch back to the LiDAR view, which is based on the point cloud, also collected with Kinesis Video's LiDAR capability. And they're going to fly through the factory here. That's, or the refinery. Those are two people who didn't stand still long enough to get scanned. And they're going to move over and take a look at these compressors here. So not only does this give them significantly greater safety capabilities, because they don't have to have a person out walking around all the time. They can get a tremendous amount of information from it. They can send the robots in to do specific inspections as needed. They also have the ability to simulate their plant and manage their plant through this interface. So it's a pretty exciting combination of robotics, IoT, machine learning, edge processing. You can see the camera processing, all fused together in a product called Fuse that they've built on top of AWS. So hopefully I've given you an idea of an overview of what you can accomplish using the tools we've created to sort of accelerate your business, save money through predictive maintenance, get better visibility to see how your factories and industrial sites are running, integrate across multiple platforms. And we continue to innovate and push more and more innovation into this space. Thanks for taking the time to listen.